the operator, could you please share your screen? We cannot start the session until you're ready to share your screen. Okay. I would like to remind the presenter to obey the rules of our session. The rule is in your screen, so please rename your Zoom account name, and the participants are required to mute the audio during the presentation. In order to respect the speaker, participants are recommended to turn on their camera, and questions could be delivered during the presentation or at discussion session in the chat box. Okay, before we start the session, I would like to announce the rules of our mini session. The first one, the participants encouraged to rename their names. Yeah, follow these rules, and the participants are required to mute the audio during the presentation, and you can unmute the audio when moderator allows the participants. In order to respect the speakers, participants are recommended to turn on their camera. Questions could be delivered during the presentation or at discussion session in the chat box. The moderator guides the discussion session, and the participants are directed to the main room or MSAT schedule for MSAT schedule and information. Okay, so the participants can back to the main room for MSAT schedule and information. Okay, maybe I can start now. A perfect morning I bid to our honorable presenters and all participants. I am honored to have all of you here in regards to the virtual international conference of Maritime Science and Advanced Technology 2021. Welcome to our first morning session. I am Faiza Adi Rahmaudin Abdullah as the moderator of this morning session. Today, we will have 6 presenters ready to share their knowledge and idea related to their research work. For any question related to this presentation, please post your question in the chat box at the bottom of your screen. Without further ado, I would like to introduce our first presenter. We have Graciela Tangkedatu from
Recording in progress.
Tadulato University. Mrs. Graciela with us. Okay. I think Mrs. Gracella is not with us, so we may continue to the second presenter. The second presenter will delivered by Muhammad Najib Habibi. He's come from Badan Meteorologi and Climatology of Indonesia, BMKG. He will talk about site suitability assessment for wave power development in Indonesia. For the operator, please play the video of Muhammad Najib Habibi.
Thank you for giving me a chance to participate in this great event, Third International Conference on Maritime Science and Advanced Technology. My name is Muhammad Najib Habibi. I am from Research and Development Center of BMKG. My research title is Site Suitability Assessment for Wave Power Development in Indonesia. Our outline presentation consists of introduction, data and method, result and discussion, and also conclusion. Renewable energy is our future. There are some renewable energy sources in Indonesia, such as solar energy, wind power, biomass, geothermal, tidal power, hydropower, nuclear, ocean current energy, ocean thermal energy conversion or OTEC, and wave energy. Wave energy is one of the environmentally friendly energy source. Renewable energy has become important because energy necessity is increasing in line with industrial development, economic, and population growth. Electric power necessity is in Indonesia projected growth 8.7% annually, and most of them fulfilled by fossil fuel. It can derive environmental problems such as
Operator,
increasing
I'm
CO2
sorry.
emission, which is
Is there
indicated
anyone
to
can
affect
hear
on
the
global
voice
warming.
of the video?
Wave energy has excellency in high density and
No,
gas continuity,
not
so it is potential to be developed.
okay.
The aim of our research is to assess the suitable site for wave power development and calculating the wave power potency.
Operator, could you please
This is
fix the
our
audio of the
research
video?
location. It is
Because
covering Indonesia
everyone
territory.
here is cannot
We use
uh,
the output of wave
hear
model
the
data with watch
audio.
3 for our research. The wave model run into two domains, global and
I
nested
can't
into
hear.
regional. We use significant wave height and wave period to
Okay,
calculate wave
Okay,
energy.
okay.
Specification of our data is temporal resolution 6 hourly, spatial resolution is 14 km, and data length is 25 years. This data has been verified by Ramdhani with satellite and buoy data, and the result is still good. We calculate the wave power with this formula adopted from Mirzai. Wave energy stability level is an essential factor in determining the site suitability of the wave power plant. Areas with a high level stability are chosen to ensure the sustainability of the electricity produced. The energy stability expressed by the presence of exceedance of PE, which calculated by this formula. We eliminate the area when the distance more than 50 nautical mile from coastal and PE on wave power density below 0.8 kilowatt per meter is more than 2.5%. We developed this model to assess suitable site for wave power development. We use overlay method to combine the wave power density, the depth, the distance for coastline, and PE. The calculation model shows in this figure. By overlaying process, all of information are merged into one map and expressed by the total score, which is calculated by this formula. ST is total score, SRG is wave power density score, SK depth score, SG distance score, and SPE is presence of exceedance score. Site suitability classes are determined into three categories: low, medium, and high. Estimation product calculated based on the electric harvester. Electrical energy calculated based on array with energy converter isolated in installation scheme. This is adjusted to the power density characteristic. We choose M3 wave, where it can work optimally in mid-short with 10 into 40 meter step and more than 10 kilowatt per meter power density. M3 wave installed on the seabed, so on it doesn't disturbing other activities such as tourism, fisheries, shipping, installation scheme, and other ecosystems. This is adjusted to the product capacity of M3 wave is 150 to 500 kilowatt, where it can work optimally in simulation based on array installation 10 into 40 meters step and more than 10 meters distance of grid power density. To estimate electrical energy product, we can install 25 tools in 1 kilometer square in the simulation. We only calculate the high category in site suitability, capacity of area in seasonal variation. It is proposed to maintain the continuity of electrical products throughout the year. Harvesting of this energy will occur when technology is available and economically also technically applicable. First and most important is site selection. The factor to be considered in the site suitability identification are the climate, geological, and seasonal density, the distance from the coast, the depth, also the VA. It is proposed to in Aceh and North Sumatra. Commonly, the suitable site is harvesting of fish dependent on the season. When it is fluctuating because the power density also fluctuating. The suitable site become wider when power density is increasing. To maintain the continuity of electrical product, we only analyze the smallest area. Aceh and North Sumatra has varied suitable area dependent on the season. The suitable area becomes 0 kilometer in DGF, but it was wider in another season and maximum in GGA. Based on this condition, we eliminate this region as selected site. When the most suitable area in province maintain the coast around Enggano and along the western coast of the coastal. The high category of such a suitability in this province are about 141 kilometers square and become wider at GGF for about 1,131 kilometers square. The most differences in other province seasonal variations in Lampung is not clearly visible. Their suitable site between 400 and 80 kilometers square. The suitable area in Banten province concentrated in Ujung Kulon. The minimum width is in DGF and become wider at GGF for about SOM, September, October, November. In West Java province, has suitable area spread out Sukabumi, Cianjur, Garut, Tasikmalaya, and Ciamis. And they have suitable area about 1,100. The suitable area in Banten province and in TJF and 1,000 Ujung Kulon and the minimum 137 kilometers square and in maximum for about September, October. The suitable area in Yogyakarta in West Java province in Kulon Progo has suitable area spread out Bantul, also Cianjur, Garut, and the suitable area in Central Java concentrated in Cilacap. They have suitable area about 1,000 and there is a significant variation based on seasonal TJF. The suitable area in East Java and the minimum 137 Pacitan, Trenggalek, Tulungagung, Blitar, Malang, Lumajang. The suitable area in Yogyakarta province in Kulon Progo has suitable the minimum width is in Bantul, TGS, and largest in and the suitable area in Central Java. The seasonal variation more visible in farming. The suitable area there is a significant variation in Badung, Selungkung in East Java, Tabanan. It is about 98 km square in ICZM and in SUM about 220 km square. Totally, the largest suitable area in Indonesia in GGA and smallest in DGF. And largest in electric energy calculated based on array with energy converters installation scheme MPP. The calculation of electrical product in every province is shown. It is about 28 kilometers. The lower threshold is calculated using 150 kilometers capacity, and totally the largest suitable threshold is 500 kilowatt based on the technical specification of the MPP.
Electric energy
The largest potential is with energy Java. It is 4.21 to 14 gigawatt hour, and the smallest is in West Sumatra, 0.21 to 0.71 gigawatt hour. Totally, the potential of electric product in Indonesia is 12.65 to 42.16 gigawatt hour. My conclusion of this research is the wave power density in Indonesia at highest level eventuating with Australian monsoon and lowest in Asian monsoon onset. It is represented by the weight of high category unsuitable area are fluctuating following the monsoon cycle. A great potential area to develop with energy are analyzed from site suitability and power density stability. They are spread out from Mentawai Island, Bengkulu, Lampung, Banten, West Java, Central Java, Jogja, East Java, and Bali with 12.65 to 42 gigawatt hour electric potency. This is our recommendation. This research is general description of potential wave power over Indonesia. More parameters such as substrate, the distance from the existing power grid, and the distance from the electrical user should be used to determine the site suitability. The more suitable site can be obtained by considering other land use, such as conservation area, shipping lane, fishery area, infrastructure, and economic studies. Higher resolution data is required to improve the accuracy of the result. Trial of wave energy converter installation are required to verify the potential site. Thank you.
Okay, we have 3 minutes. 3 minutes to do question and answer session. Is there any question from the participants?
evaluate the presence of oxygen. So when the energy is in 0.8 kilowatt per liter is more than 2.5%, we eliminate this grid for our calculation. So this selection site, it is more from seasonal variations such as monsoonal cycle. Selected site is the selected site is calculated our selected site is because we analyze seasonally and also climatic. Based on our research before this research, we also calculate all over Indonesia and manufacturing the potential site is in Papua, but this site is not persistent because in another Australian monsoon, the PA of percent of oxygen is more than 2.5%. So to eliminate this area, it is in development of this energy, we need continuity. So we eliminate the area where the percent of oxygen is more than 2.5%. Based on another research, for example in Malaysia, they have installing this energy converter, but the VAC or this energy converter only operating in 5 months because the energy is not working. Their energy is not converted. It not can be converted in Australian monsoon.
It can answer Mr. Jonathan's question. Presenter. It will be delivered by Mr. Jonathan.
Hello everyone, my name is Johan Sandi from Marine Research Center. On behalf of our team, I would like to share our investigation on the increase of mean water level that is induced by wave breaking or the so-called wave setup across the north region of West Java. The presentation will be divided into some sections. Firstly, I will be shortly talking about the background and the objective of the mission. Secondly, the description of the study area and the way the Hello everyone, my name is Johan Risandi from Marine Research Center. On behalf of our team, I would like to share our investigation on the increase of mean water level that is induced by wave breaking, or the so-called wave setup, across the north region of West Java. The presentation will be divided into some sections. Firstly, I will be shortly talking about the background and the objective of the research. Secondly, the description of the study area and the way the data was analyzed will be discussed, and followed by the explanation of the result and discussion. In the end, I will summarize the talk and wrap up the conclusion. As we know, flooding is one of the most common hazards in coastal area, although many factors impacting the flood, for example heavy rain, but in this talk we concern on the flooding caused by the increase of seawater level that comes frequently. A study reveals that the loss due to the flooding could be 20% of world GDP by the end of 21st century. So what about in Indonesia? Well, in many places in Indonesia, coastal flooding also causes severe impact on the economy. For example, as we can see in this picture, where water blocked all of the access, slowing down the activities. I haven't got any proven reference on the total loss due to this hazard for the whole country, Indonesia, but I found some literature on some region, for example in Jakarta or Semarang, that it costs billion rupiah per year. So what is the cause of coastal flooding? There are several factors contribute to the increase of water level causing flooding. In general, we could identify three main sources. The total water level is firstly caused by longer-term sea level increase for more than, let's say, 6 hours. That is the astronomic tides and non-tides parameters, for example, La Nina or other regional forcing like Lewin current in Australia. The second comes from storm surge that's caused by low barometric pressure or direct wind stress resulting wind setup. The third is wave-related contribution, namely low-frequency modulation or infragravity waves with period of 25 to 300 seconds, as well as the swash exertion in coastline due to the incident waves, as well as again because of the IG waves. And the last will be, which will be the focus on this talk, is the mean wave setup, that basically an increase of mean water level due to the wave breaking within surf zone that push water landward. And wave setups depends on the beach slope and breaking condition. So a question arises is that why the topic is so interesting. Firstly, wave setup plays important role to coastal inundation. Therefore, to know how much the contribution to total water level in coastal region is pretty interesting. Secondly, in Indonesia, the study of wave setup contribution to total water level is rarely discussed. Most study, as I know, is limited to water level increase due to tides. Hence, the main objective of this research is to investigate the wave setup fluctuation at the north coast of West Java. The study area is located in Cirebon region, which is located between Indramayu and Losari, Central Java, as we can see inside the red box. Similar to other coastal area within Java Island, the region also experienced frequent coastal flooding. That in particular month, the flooding become more severe. For this purpose, we use Delphi wave with numerical domain of study span between Losari to Indramayu, as we can see inside the picture. We also use curvilinear grid that cover around how many is it? 2,500 kilometers square with variable grid sizes. The wave forcing as the input was set into single wave condition with significant wave of 2.2 and peak period of 6.8 seconds that propagates from three main directions, that is northeast, north, and northwest, representing what is happening in the study area. In addition, wind forcing was also uniformly imposed within the offshore domain with a single speed of 8 centimeters, and the main direction of the waves are parallel to the direction of wave forcing. Wave setup, in general, basically the difference between offshore and nearshore water level. In Delft 3D, it was calculated from as a function of wave force and hydrostatic pressure, in which uh, the setup on the offshore boundary is assumed to be 0. The result of wave model for 3 different scenarios are shown here. We can see that the nearshore of Cirebon was the roughest when the wave traveled from northeast, which is in the left side of the slide. It also represents what's happening during the east monsoon. In contrast, at a similar wave condition, but when the wave travel from west, the nearshore of the study area was much more calm, and it represents the condition during west monsoon. And the condition is expected because of the domain is sheltered by the land on the west part of the of the model that block the wave generation, as we can see on the yellow circle on the right figures. Interestingly, when the wave come from the north, even though the north boundary, as we can see, is open sea, the waves near the shoreline was relatively calm. This because of mega sandbar located offshore within the yellow circle on the right images, that in which the mega sandbar dissipate most of the wave energy before reaching the coastline, and it creates some semi-protected system from the excessive waves, except when the waves travel from the east. The sandbar here, the mega sandbar, is possibly developed from river discharge, which is located nearby the sandbar, and the result of longshore drift during wet season. In this slide, we shows the resulting setup for 3 different wave scenario, which are proportional to the model wave height. The setup, the maximum setup for these 3 models occurred during east monsoon, with the height of setup is 15 centimeters, and as we expected, the minimum setup occurred during west monsoon. Among 3 models, the setup was relatively higher at the area with steeper bottom profiles, as we can see here on the red circles. And from this result, we could conclude that the setup is not too significant, because it was only around 15 centimeters that occurred during east monsoon, and there are 2 possible reasons for that. Firstly is due to weak offshore wave energy that occurred in Java Sea compared to other area like Indian Ocean with maybe 5 to 6 meter wave height. And the second is due to the flat bottom profile of study area. However, the combination of the setup with other forcing, for example tides and other regional forcing, the setup could give severe flooding to the low-lying area, like we can see in the following slide here. As shown here, flooding has caused inundation on stream ponds and housing nearby the coastline. Specific to this, the right images, we took a peek the actual condition when we did the survey there, and considering the climate change and sea level rise issue, the contribution of waste setup to flooding will be more in the upcoming years. In summary, the model showed the wave patterns across the study area are mainly influenced by the bottom profile and wave directions. During each season, the nearshore wave energy was higher because of less obstacle. Meanwhile, the wave propagation from the other directions saw larger dissipation by shallower region that is sandbar and the inland on the west part of the model domain. As a result, the setup was also higher during east monsoon, with the maximum of the setup around 15 centimeters at the area with steeper profile. Although the setup seemed to be insignificant, there is 15 centimeter. The contribution of the setup with other forcing like tides and, for example, the IG waves and the wind setup. Chirborne area with low-lying elevation is still vulnerable to flooding. Okay, that's all my presentation. Stay safe, and thank you very much for watching this video.
Okay, thank you, Mr. Johan Risandi, for the video. I would like to invite the participants to ask Mr. Johan regarding this presentation. You have 3 minutes in chat box.
My voice clearly, or
Yes.
okay, cool. Yeah, so in our simulation, we use only level. The title is important. It is related to the location of breaking. So wave setup is related to wave breaking that push water onward. Indirect result for the wave setup. So in this simulation, we check but of course, if we increase the water level, for example, the tide, or maybe to do other phenomena like the IG wave or other longer term, for example, the setup would be higher, and then also basically consider to the extra event, since here the input for the investigate the wave condition at the time for the whole years, but I'm pretty sure that maybe the result is a bit underestimated, since of course a lot of extreme events has to be considered. Yeah, so that's my answer. Is it clear, or you need more explanation?
Mr. Najib, does it answer your question? Okay.
Yeah.
Okay.
Yes, but when the title and also wave is in one time occurring, so it is caused exponential increases of water level. So I think the title is title also important in wave setup.
Yeah, indeed, you're correct. Tidal is important, but mostly wave setup is caused by wave breaking, and then tidal was it the increase of water level due to tide affecting the location of breaking. Yeah, and then it will also influence the setup generation. However, I also try to calculate setup not using this model, but different models. Like I use a phase resolving model, SWASH, which is much more complicated than the L3D. The setup is, impacted by water level modulation due to tide. But we exclude here because what is the name? We want to give you flavor what's happening during wave event. So of course we can also increase the accuracy or maybe the result by including tide in our model. Yeah, I think that's the answer, Mr. Najib. Maybe
we have to continue to our next presenter. Okay, for the next presenter, I would like to invite Mr. Liu Changlong for the Jiang University. He will talk about the atmospheric boundary layer in the presence of surface waves. The operator, please play the video of Mr. Liu.
Need me to play the video?
Oh, you want to directly present your presentation?
I thought I was uploaded the video to you. Or I need to share my screen.
Oh yeah, sure. You can share your screen if you not upload the video yet.
Yeah. I am uploaded. If it's not convenient, I can play the video in my computer.
Okay.
Okay. Thank you.
Maybe you can share your screen first, Mr. Liu.
Okay.
So we can see your video.
can hear this?
Okay, we can
Okay.
see your video.
Okay, thank you.
But sorry, we cannot hear the voice. Could you please also share the? We cannot hear the voice. We cannot hear the audio of your video.
No voice.
Yeah, no voice. Could you share with the audio, not only not just the video, but the audio also?
Oh, okay. Now can hear the video?
Not yet.
Oh. Could you play the video? Because I don't expect I will present the video. So maybe some problems. Very sorry.
I would like to ask the operator.
Ladies
first.
and gentlemen,
The operator,
it's my great honor to attend this meeting, the third International Conference on Maritime Sciences and Advanced Technology. My name is Li Xiangyu, a graduate student from Ocean College, Zhejiang University.
Oh, thank you.
Majoring air-sea interaction in physical oceanography. The content of my presentation is atmospheric boundary layer in the presence of surface waves. And this is a part of my research direction that my partner and I are studying. Now I begin my formal presentation. The contact reaction of my presentation is between ocean wave and adjacent airflow in the fact the function of Earth's climate and weather system as they control the exchanges of momentum, heat, and gases between the atmosphere and the ocean. However, our physical understanding of air-wave interaction remains incomplete. In recent years, the marine atmosphere boundary layer ABL draws more attention recent year because observation, model, and large eddy simulation shows that Morning-Uphoff similarity theory is invalid within the wave boundary layer WBL. The WBL is defined as the region of the marine ABL directly impacted by waves. Most is the first derived on rigid lined surface based on the log wind profile. So, the analysis of our observations is compared with finding overlined. Within the marine ABL, the total wind stress tau is a vector, where I and G represent the along wind and crosswind unit vector. U, V, and W are the fluctuation of the wind stress velocity components around their time average value, where I and G respectively, and rho is the air density and crosswind unit vector. In practice, the wind stress equal to momentum flux because the magnitude fluctuation is numerically equal to absolute value of tau, where tau is a vertical momentum flux and is defined to be positive downward from atmosphere to ocean. Within the WBL, the fluctuation of wind velocity can be divided to turbulence and wave-induced. Thus, above the viscous sublayer and the total wind stress is the sum of terminal stress tau T and wave-induced stress tau W, which is a relationship as follows. Over the ocean surface, Money upholds similarity theory, which originated from rigid line surface, is widely used to relate the total wind stress to the mean wind profile. So, the field observations used in this study were collected in the South China Sea over the period of 2012 spring. The observation site is about 6.5 kilometers away from the coastline, and the mean water depth surrounding is set about 60 meters. Due to the complexity of environmental conditions, field observations should be subjected to strict quality control procedures, and the wave age was used to selected to two kinds of cases: wind sea conditions and swell conditions. We can see the first figure is showing that velocity spectrum under the wind sea condition on the left and swell condition on the right. Under wind sea conditions, all measurements had above WBL. Black line is a wind velocity spectrum, and blue line is a wave velocity spectrum. This peak physiologued with wave in swell conditions, whereas there is no perturbation induced by wave in the wind condition. Thus, the turbulence structure are constant, and that in the lined ABL and the mean wind profile follows most. And the next figure shows that UW co-spectral under the wind sea condition on the left and the swell condition on the right. Blue line is the frequency of the dominant water. There is a kind of difference between the two figures. Pronounced swell-related peaks appear in a velocity spectral and UW's co-spectral when the sea state is dominated by swell, suggesting measurement is made within WBL and the overlying airflow and air-sea exchanges are strongly modified. It is negative at all frequency in wind condition, meaning momentum is transformed from air to ocean, but under swell conditions, swell induce an upward momentum flux. It is a common pretext to take a long wind stress tau x as a total wind stress because a cross wind stress tau y is too small to exchange the magnitude and the direction of the total wind stress. However, under swell condition, our observation shows that swell not only can lead a long wind stress to reverse its thing, but also can cause a large portion of cross wind stress, resulting in misalignment between the stress vector and the wind. So, due to time constraints, my research result can only present a limited part. If you have any question, please communicate and discuss with me. At the same time, welcome to pay more attention to my research field and directions. Thank you for your listening.
Okay, thank you for the video, Mr. Liu.
Okay, thank you.
Yeah, next we have 3 minutes time for question and answer.
Okay.
I would like to invite the participants. If you have any question regarding the Mr. Liu's presentation, you may directly ask to Mr. Liu or write in the chat box.
Expected problem.
Okay.
Thanks for your asking. The biome is used to measure the waves and which is located nearby the observational tower, which is shown as figures in this presentation. And the observation site is about 6.5 kilometers from the coastline. This site is dominated by swell in most of the times. Provide a very good environmental condition to studying the swell's influence on the airflow.
Okay, Mr. Johan, should answer your question. Okay.
Okay, thanks for your asking.
Okay. I think it's enough, Mr. Liu. Thank you.
Thank you.
Okay. We may continue our session. For the next presenter, I would like to invite Mr. Putu Ferry Swastika from Department of Mathematics of ITB. He will talk about the momentum conserving scheme implementation for simulating dendritic flow through various contraction. The operator,
good day. Thank you to the committee for giving me the opportunity to present here my works with my supervisor. Let me introduce myself. My name is Putu Ferry Swastika and I am a PhD student at Bandung Institute of Technology, Indonesia. Here, I would like to discuss some mathematical application for modeling and simulation of a dam bridging or dam break. Our project title is the Momentum Conserving Sim Implementation for Simulating Dam Break Flow through Various Contraction. Our talk will be a quarter of an hour, so it won't be too complicated. But here we just want to show our work in a modeling and simulation perspective using a mathematical equation called the Saint-Venant equation. This equation is well known and widely discussed in various fields. Our content of discussion today will be divided into 5 main parts as shown on the screen here. So here we will show you 2 videos of the dam break disaster around the world. On the left side is the video footage from Associated Press. It is showing us the Situ Gintung Dam here in Banten, Indonesia. The dam is breaching back in 2009 on the dawn of March 27 and killed almost 100 people. On the bottom side, it is the video footage from the Hindus channel. It is also showing us the moment of the Brazilian dam breaking in 2019. On January 25, a mining dam that sat above Brumadinho, a large town in southeastern Brazil, collapsed and unleashed a tidal wave of waste and mud that engulfed homes, businesses, and residents in its path. It killed at least 157 people. 182 are still missing. Well, on the top right is a simulation of a dam break. This is from our class project in 2018 actually. In this talk, to accomplish those, we will simulate the dam break phenomena on a laboratory scale using modeling and simulation. Instead of using a 2-dimensional or 3-dimensional mathematical model, which is high-cost computation, here we will assume that we will use a 1 quasi-dimensional model. It means that we only consider the flows along the axis X channel. Consider a fluid bounded above by a free surface and below by bottom topography z equal to minus dx. The flow is assumed to be one-dimensional flows with varying channel width, px. The motion of the free surface can be governed by the Saint-Venant equation. Don't worry, don't be panic, we are not trying to scare you, but the equations are rather simple. Only a couple of equations, equation 1 and 2. Here, we restrict our discussion to the rectangular cross-section, so the A is cross-sectional area, B is the width, and etc. and etc. Now, to make us easier to do simulation, we will simplify equation 1 and 2, and using expression 3, we can rewrite equation 1 and 2 to be equation 4 and 5, which is more simpler. Remember that for the rest of our discussion today, equation 4 and 5 will be used for simulation of the dam break phenomena. For the numerical approach, an accurate approximation of the Saint-Venant equation, equation 4 and 5, require a suitable approximation on the nonlinear term. Here, we adopt the momentum conservative approach applied on a staggered grid as originally proposed by Stelling and Duinmeyer on 2003. This scheme has been further developed by several authors, including our teams, and gained its name, the Momentum Conserving Staggered Grid Scheme. In this section, we discuss the numerical scheme for solving equation 4 and 5 using the MCS. We consider the governing equation on the spatial domain X element interval A until B and uniformly discretized with a spatial step size a half of delta X with A and B element real number. The resulting partition point from this configuration is as follows, where nx represents the number of partition points. In this staggered grid configuration, we approximate the mass conservation 4 at half cell, whereas the momentum 5 is approximate at full cell. So, we have discrete numerical approximation scheme read as follows. Where most discussion in this paper will consider flat bottom dx equal to 0. Further, we computed the following variables consistently in stagger grid. Remember that we approximate variable cross-sectional area A in the full grid, but here A is needed in the half grid. We don't have that value, so we need the approximation of A in the half grid by using upwind approximation as follows. Okay, now we will be discussed how to approximate the nonlinear terms in the green circle. There are many ways to approximate the nonlinear terms, but here we will apply what Stalling and Dwinmeyer proposed as a momentum conservative approach. Remember this relation? Then, the consistent approximation in the discrete formulation is. Remember that we approximate variable velocity u in the half grid, but here u is needed in the full grid. We don't have that value, so we need the approximation of u in the half grid by using upwind approximation for u as follows. So, the MCSM for the Saint-Venant equation are equation 6 until 9. The same is semi-discrete explicit approximation of the linear terms are second order, but the approximation for the nonlinear terms are first order. Okay, next we will talk about laboratory scale damping experiment through contraction carried out by Kocaman et al. In 2020. The laboratory experiment worked in a rectangular horizontal channel with the following dimension. See Figure A. The reservoir upstream was swarmed by a vertical gate representing the dam located at a distance of 4.65 meters from the left boundary and filled with water up to a depth of 0.25 meters in the initial state. The downstream section was initially dry and the right boundary is open so that the flow would fall freely without reflection. See Figure B. Three types of contraction, two trapezoidal and one triangular, are placed in the contraction zone in such a way represent transition from smooth to sudden contraction. See Figure C. Figure 3 presents a snapshot of the fluid surface obtained from the numerical calculation of a dam break in the canal. All results are presented in the non-dimensional water level h and the non-dimensional time t. The gate representing the dam is lifted suddenly, causing the water level in the upstream reservoir will gradually decrease and propagate downstream through contraction area as a fluid wave. Further, along the canal, there are 4 observation locations where the water level were recorded at all times. 4 gauges are indicated by cross: gauge 1 blue, gauge 2 green, gauge 3 magenta, and gauge 4 brown. Here we present the time varying water level at gauge G until G4 from numerical versus experimental for a channel with trapezoidal A contraction. Here we present the time varying water level at gauge G1 until G4 from numerical versus experimental for channel with trapezoidal B contraction. Here we present the time varying water levels at gauge G1 until G4 from numerical versus experimental for channel with triangular contraction. So we arrive with the conclusion for our discussion. We have studied numerically the dam break flow in channel with 3 different contractions, 1 triangular and 2 trapezoidal. The simulation results show good agreement with the experimental data in the literature. This assessment shows the merit of the sim, which is suitable for dam break flows in channel of varying width. It should be noted that for simulation of this two-dimensional dam break flow event, the MCS numerical sim that we use is relatively cheap because it is based on a quasi-one-dimensional model, but it has been able to provide fairly good accuracy. Thank you.
Okay, thank you for the video, Mr. Putu. I would like to invite other participants. If you have any question to Mr. Putu, you can directly ask Mr. Putu or write your question in the chat box. Condition on the left side of your simulation. Could you please explain it after the dam is break and what happened on the left boundary?
Okay, thank you. Can you hear my voice clearly?
Yes.
Yes. Okay. Thank you. Very nice question actually. So for it is a technical, I think. So on the left side, I use hard wall boundary. So oh, sorry. On the left side, I use yeah, hard wall boundary, but on the right side, we use absorbing boundary. So it the flow on the right side will be fall freely or absorb it, but on the left side, it's bounce back again to the right.
So there is a refractive wave after.
Yeah, actually, when the flow when the gate is lifting, and then the flow is reaching the contraction area, it's, let's say, there is some small reflection and bounce back to the left and then bounce back to the right again until it's all absorbed by the right boundary.
Okay, thank you.
Okay, thank you.
From other participants? Do you have any question for Mr. Putu? Oh, we have a question from Mr. Najib in the chat box. Is your formula can be applied for another aspect, for example, to predict the erosion of coastline? Mr. Putu, you can directly answer the question.
Yeah, okay. Thank you, Pak Najib. Actually, maybe, but I'm not so sure about the prediction of erosion. But if it can be predicted erosion, maybe it can be study more further about it, because actually my model, my numerical model is talking about some dam bridging, something like that. but if the erosion is something like the dam break event, I think it can be used for modeling the erosion of coastline. But I'm not so sure. So it's yeah, we must study it more further, I think. Thank you.
Okay, I think it's enough for Mr. Tutu session. We may continue to our next presenter. Our next presenter is Mr. Lee Sin Yu. I don't know, Mr. or Mrs. Are you here, Miss Lee Sin Yu?
Hi, excuse me. Yeah. I am Liu Changlong, and Li Xinyu is my co-worker, which is unfortunately due to some environmental limit, he cannot see the word. So please you play the video, and I will do the Q&A section.
Okay.
Thank you.
Okay. Yeah, the video will talk about the temporal and spatial distribution characteristic of wind wave energy and surge energy in China Sea and its surrounding waters. Mr. Lee Sin Yu is from the Young University. Dear brother, could you please play the video?
It's my great honor to attend this.
Okay, thank you for the video, Mr. Sin Yuli. I would like to invite the participant to ask Mr. Sin Yuli regarding the research work. Okay, we have one question in the chat box. It's come from Mr. Najib. Mr. Sinyuli.
Okay.
Yeah. Maybe I will read the question for you. Is your climate data of wave and wind also include the typhoon event?
Yes. It do include the typhoon event.
Okay.
Yes, I think it will cause the ambiguity in harness its energy because during our analysis, the unique large value wave height maybe mostly associated with the typhoon event.
Is there anyone to ask more question? Oh, Mr. Ryu, are you with me? I cannot hear your voice. Mr. Ryu? I think I think because of maybe technical problem, we cannot continue the discussion with Mr. Ryu. Mr. Ryu, can you hear me? I cannot hear your voice. Okay. Okay, I think enough. Yeah, Mr. Lee Xin Yu is the last presenter of our session. I think this is the end of our session. I hope all of you get new insight regarding the ocean wave research work from our honorable presenters. Thank you for all presenters and participants. For your information, we still have 20 minutes for polarization. You may move to other mini session by choosing breakout room in the bottom of your screen. Okay, I think that's all. Thank you very much. See you next time. Bye.
Recording stopped. Recording in progress.
Kemudian kebanyakan juga menjadi konsultan. Di sini konsultan cuaca itu pekerjaannya seperti memberikan analisis cuaca tentang bagaimana suatu keadaan itu harusnya dilakukan. Umumnya mereka bekerja di perusahaan seperti pertambangan, perminyakan, dan pertanian. Ada juga lulusan-lulusan dari kami itu yang menjadi kepala departemen di BPPT dan kepala departemen di BMK.
Jadi sekarang saya akan menjelaskan tentang prospek lulusan oceanografi. Untuk lulusan para oceanografi biasanya terkonsentrasi menjadi 3 bidang, yaitu adalah seorang peneliti, menjadi seorang surveyor di lapangan, atau bahkan menjadi seorang analis di suatu perusahaan-perusahaan. Dan di sini untuk peneliti sendiri biasanya untuk mahasiswa yang ingin melanjutkan studi di berbagai universitas dalam atau di luar negeri, seperti Tokyo Institute of Technology, di Hamburg University, atau bahkan bisa sampai Massachusetts Institute of Technology. Dan untuk field surveyor itu bagi orang-orang yang suka kerja di lapangan, tapi khususnya di laut. Contohnya di perusahaan seperti Schlumberger, di perusahaan Fugro, atau perusahaan seperti Pagio. Dan yang ketiga adalah sebagai seorang analis lingkungan. Biasanya dibutuhkan untuk memberikan informasi kepada perusahaan-perusahaan yang melakukan industri migas atau pertambangan. Di sini seperti Freeport, Newmont, atau juga bahkan perusahaan minyak seperti Pertamina, Total, atau bahkan British Petroleum.
Geodis itu sebenarnya bisa bekerja di mana-mana nih ya. Jadi untuk melakukan sebuah kegiatan tentu kita butuh perencanaan. Geodis itu bisa mulai dari sebelum perencanaan untuk merencanakan pemantauan sampai evaluasi itu kira-kira. Jadi kita bisa bekerja di manapun, BUMN, minyak, apalagi perusahaan yang butuh survei atau peta offshore, ya pegawai negeri juga bisa lah, BPN atau BIG gitu.
Prospek kerjanya itu biasanya lulusan geologi ini masuknya ke industri, apakah itu industri perminyakan,
halo, apa dia jadi?
ataupun industri panas bumi. Tapi tidak sedikit juga lulusannya menjadi dosen, ataupun konsultan, ataupun orang-orang yang bisa keluar dari
Established in 1920 with the name Technische Hogeschool te Bandung, Institut Teknologi Bandung is the oldest technical university in Indonesia.
Ladies and gentlemen, we kindly remind you that we will have two keynote speakers this afternoon. Dr. Wenju Chai, the Director of Center for Southern Hemisphere Oceans Research, Australia, and Dr. Yasumasa Miyazawa, the Deputy Director of Application Laboratory, JAMSTEC, Japan. For all participants, we kindly remind you that the list of attendance can be accessed through the link provided on the chat room. We will also hold another parallel session afterward, and each session has different topics as shown later on your screen. And participants are allowed to join the room to your liking. For more information, please check our website at msat.fitb.itb.ac.id. In the meantime, we will have lunch break for 90 minutes. See you at 1 p.m. Indonesian Western Time.
So today we will have 7 presenters with one invited speaker, Dr. Jiang Ling Su, who will play. Please correct me if my pronunciation is not correct.
Yes, that's correct. Thank you.
Thank you very much. Let's start with these mini sessions with invited speakers. Please, Dr. Jiang Ling Su, time is yours.
Okay. Okay, thank you. Thank you for your invitation. Now I'd like to share my screen. Okay, here. Can you see my screen? Okay. Okay, thank you. And now I want to launch it. And that's so glad, and I'm just so honored to be invited to the third MSAT. And this is also my third time to attend to such a conference. And it's really impressive. The international conference has already lasted for 3 years. And I'd like to express my congratulations to the committee. That's a really good job. And now I'd like to show you one project we just finished. Sorry. And this project is about the development and application of comprehensive decision support system for maritime emergencies and maritime search and rescue. This project is funded by the National Key Research and Development Plans. We hosted the project, and the participants including Tsinghua University, National University of Defense Technology, and Shandong University of Science and Technology, as well as the First Institute of Oceanography and the Third Institute of Oceanography, as well as the Monitoring Center of North China Sea and East China Sea. So it's a very big project, and I'd like to show you some results of this project. The reason we did this project is because in recent years, there are many marine emergencies happen frequently, such as the oil spill event in 2008, as well as the hazardous materials and the radioactive material leakage, and also many traffic accidents. So that causing a large number of loss of life and property, and cause serious environmental pollution. That's hence we referring to some systems developed by USA as well as Europe and Japan. There are different there are many different systems to deal with the emergencies, like for the hazardous chemicals and the radioactive, and also maritime search and rescue. Based on these studies, we developed we aim to develop our comprehensive and intelligent system to deal with all these emergencies. Here is our research objectives. We taking into account the decision-making thought of the battlefield to address the many problems in the process of emergency response, like the information discrete and the insufficient situation analysis, and the subjective decision-making and the inefficient response. The main idea is to integrate multi-source monitoring data and break through key technologies and develop one intelligent, interactive, and integrated offshore emergency response and maritime search and rescue decision support system, and in the end to realize the operational application. So the design scheme is like this. Our since our system is fixed to the decision makers and the decision-making process, so that covers the whole process of emergency response, from the risk source identification to the multi-source data integration, and to realize the scientific situation deduction. We, based on the accurately grasp the current state and the event development, we can then realize the intelligent scheme generation and the task distribution. So in the end, we get one big comprehensive command system. Like this is the main page of this system, which is based on one big database, include all the data and all the models, like for the oil spill subsystem and the hazardous chemical subsystem and the radioactive subsystem, also the marine time search and rescue. You can see for the oil spill, based on this system, we can give the result for the trajectory forecasting. Here, after we got the information of the accident, we can give the trajectory forecasting immediately, like this blue line shows. And after that, we can also show the swept area of the oil spill, like the the yellow circle. Based on this, we can design the monitoring location, like the red points. That's the monitoring location along the trajectory. After that, we will get the cleanup scheme, including the equipment and the itinerary, like the green one lines. You can see we can show the decision makers to set up the equipment to do the cleaning up. And also it shows the video of the live disposal, like this. It can be transmitted from the level to the system. As well, it has the real-time monitoring of the wind and the current, as well as the wave forecasting. And for the hazardous chemicals, we also can give the different predictions, like the diffusion prediction. It can be shown from the picture. And based on the prediction, we can set the warning region. Here is shows the red circle, and it's the warning region. And based on that, we can set up the monitoring with the UAV and unarmed ship. And also, we can design the cleanup scheme with different equipment. And for each equipment, like the ship or the UAV, it has its own task, and the task can be distributed to each unit. Besides, it can also show the video of live disposal. And for the radioactive leakage, we can also use this system to bring to give the emergency suggestions, like the monitoring locations for the marine environment. And we can also get
it's problem. Yeah. Pani, it's problem.
I think Miss Jialing's to have a connection problem.
Yeah.
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 Please unmute, Miss
Please continue, Dr. Jiangling.
Sorry for the
It's
the
okay.
internet is not upload. Okay, can you?
Yeah.
Am I back? Okay. Now
Yes.
we are moving for the radioactive leakage. It also gives some emergency suggestions based on the this system. As I show, we can show the decision makers how to put the monitoring locations according to the prediction of the diffusion. And also we can give the maritime traffic control, like the circle shows the area. And based on that, we can also organize the personnel evacuation. In this system, it also can show the real-time monitoring of the wind and the current as well as the waves. The last one is for the maritime search and rescue. And this one has been already used in many different units. For this system, it can give the trajectory and the searching area forecasting, like the red circle shows the searching area. And based on the forecasting, we can set up different boats, like the nearby boats or some professional rescue unit. And then we can give the searching plan for each boat. It has its own searching area and as well as the searching routine. All these tasks can be distributed to different ships. Here is also the video for the live rescue. You can see it can be saved by the airplane. So based on all these systems, we give the emergency response scientific support. And here is a brief introduction. Thank you. Sorry, I can't hear you. Excuse me.
Yes, thank you very much. Sorry, I was muted. Yeah, thank you very much, Dr. Jiangling. Actually, you still have a remaining time actually for presentations, but you already finished. So let's move to the discussions. I think we have more than, I think actually the discussion session is only for 5 minutes, but now we still have a remaining time for 7 minutes then. So anyone who has questions, please. You can give a question directly. Please, anyone? Is there any questions for Dr. Jiangling? Ibu Engki, probably?
Not yet.
Yes, please, if you have any questions. Hanif, do you have any questions?
Maybe I have just one question, I think. Yeah. Thank you, Dr. Jiangling Su, for the presentation. Yeah, when based on your presentation that in your you already developed some of a program that to observe the for the SAR or emergency case in China, and also it's able to observe the oil spill condition so that we can prevent the oil spill emergency. But is it possible to use that that research that we can observe the marine debris in the ocean? Is it possible?
Sorry, you mean for the oil spill?
No, I mean for the you have you can use that program for the, or observation for the oil spill, but is it possible to use that program to observe the marine debris in the ocean?
What degree?
Marine debris, plastic waste,
marine waste.
Oh no, not the wings.
No, I mean the waste.
No, the plastic, waste and the plastic.
Plastic waste,
No, not that. Not that kind of materials. Only for the oil spill because it can be monitored by the satellite. We use the satellite to do the monitoring, as well as for the emergency. If there is an accident, we send out the boat. Otherwise, there's no boat on the marine, on the ocean. So we can use the satellite to do the monitoring. But for the plastic or some minor plastic or some waste, there's no such monitoring. So we haven't included that in this system, but only for the chemicals. The chemicals can be monitored by some buoy and also the stations in the ocean. So that's the reason we can do the observations for the chemicals.
Okay, thank you. So it's
okay. Thank you.
Thank you.
Thank you very much, Dr. Jiangling. I'm sorry, there is probably background sounds. So, is there anyone who wants to give a questions, please? There is no, then I have a questions for you actually. So, in your system, I mean, in your development software, is there any use of numerical modeling?
Yes, we use many different models. Like for the oil spill, we have 2D and 3D trajectory and fate tracing back models. And also for different chemicals, we use the diffusion prediction model. And based on this, since all these models need the environmental forecasting, so we have the operational forecasting for the wind, current, and as well as wave. All these models can be integrated in this system. So the system integrates all the forecasting data, and we do the forecast for operationally, like we give the result for 7 days forecast each day.
Thank you very much. I think
thank
it's
you.
very
Thank
interesting.
you. Thank you
yes,
for your
very
question.
interesting, I think. Yes.
Okay. Thank you.
So, anyone has a questions? Because I still have one question actually, Dr. Jiangling, but it's okay. Let's give some chance to the audience, I think. So, anyone who has questions? More questions? If there is no, then I would like to ask you one more questions.
Okay.
It's regarding satellite data. Can we also integrate in your system? Satellite data. Thank you.
Yeah, satellite data and also the buoy data as well as the oceanic stations. We integrate all the observations along the coast and in the middle of the ocean. Since it's a project for the national, for the whole nation committee of the emergency response. So it includes all the observations we can get, like the satellite for the satellite for the based on the satellite image, we can get the result of the oil spill and also the green tides and some different for the sea ice and like this one, we can get the result from the satellite image.
Thank you very much. I think
Okay,
it's
thank you.
very interesting. So yeah, we need to have a discussion later.
Okay, thank you.
Later.
Thank
Okay.
you for your question.
Yes. Thank you very much, Dr. Jiangling. I think we need to move to the next presenters. And Panip, I'm sorry. Yeah, you also will be presenter, I think, in these sessions. Is that correct?
Yes, Pak.
Oh, I'm sorry. I thought that you joined us also as this committee. Okay, let's next. We move to the next presenters. It will be Adinda Maharani. Thank you very much, Dr. Jiangling. Yeah, actually, I would like to give a very big applause, but it's rather difficult to give a big applause here. But a very interesting presentation. Thank you very much. And let's move to the next presenters. Adinda Maharani, that will be delivered the presentation through a video. Please, the committee, please help me to start the video. Thank you.
Hello everyone, good afternoon. Let me introduce myself. My name is...
What's the problem? What's the problem with the video? I'm sorry, Panik.
Yes, we still
Hello
working in
everyone,
the
good afternoon.
technical
Let me introduce
problem.
myself. My name is Adinda
So
Maharani.
please, yeah.
I'm from the Earth Science
Wait a
Faculty
minute.
of Bandung Institute.
I'm sorry, everyone. So we are still waiting for the video. It will be coming soon, I
Hello
think.
everyone, good afternoon. Let me introduce myself. My name is Adinda Maharani. I'm from the Earth Science Faculty of Bandung Institute of Technology, and today I will present a presentation about potential source analysis of macro debris in Untung Java Island using trajectory particle modeling. This is outline for
Is there
today.
any technical
I have 6
problems?
points. Hello everyone, good afternoon. Hello everyone, good afternoon. Let me introduce myself. My name is
Yeah,
Adinda
I think
Maharani.
we are
I'm from the
facing
Earth
with
Science
the
Faculty
technical
of
problem.
Bandung Institute of Technology,
Maybe some
and today
connection
I will
problem with
present
the
a
operator.
presentation about potential source
Really?
analysis of macro debris in Untung Java Island using trajectory particle modeling. This is outline for today. I have 6 points. The first is background. Macro debris is highlighted problem in Untung Java Island, and this is the news about macro debris. Hello everyone, good afternoon. Let me introduce myself. My name is Adinda Maharani. I'm from the Earth Science Faculty of Bandung Institute of Technology, and today I will present a presentation about potential source analysis. Hello everyone, good afternoon. Let me introduce myself. My name is Adinda Maharani. I'm from the Earth Science Faculty of Bandung Institute of Technology, and today I will present a presentation about potential source analysis of macro debris in Untung Java Island using trajectory particle modeling. This is outline for today. I have 6 points. The first is background. Macro debris is highlighted problem in Untung Java Island, and this is the news about macro debris. So much bad news about macro debris in Untung Java Island. Macro debris has a positive correlation with population, but in this case, in this island, it's not same. Untung Java Island has a low population, just 64 people. But the amount of debris is so high. Because why? The Untung Java Island is located in Jakarta Bay and closer from Java Island. Java Island is an island with high population that produce macro debris every day, about 50,000 tons. Jakarta Bay has 13 dirty estuaries that produce debris 14 meter cubic every day. The estuaries is the source point of macro debris, but we don't know which estuaries is the potential source of macro debris in Untung Java Island. So, the purpose of this research, first, to know the most potential source of macro debris in Untung Java Island, and the second is find out which estuary is the biggest debris supplier to Untung Java Island. The research location in Untung Java Island with simulation model area in Jakarta Bay. 5 estuaries will be source point. There are Cisadane estuaries, Angke estuaries, Ciliwung estuaries, Cikeas estuaries, and Citarum estuaries. I download wind data from Europe Center from Medium Range Weather Forecast, tidal data from prediction tidal height of Mike, bathymetry and coastline data from the Hydros, and I will verification data with root mean square error method using tidal data from IOC level monitoring. We use hydrodynamic model and trajectory particle model using Mike 21, and this is scenario of model. We use pre-reclamation condition, so coastline and bathymetry in Jakarta Bay without reclamation. We simulated model in 1999 and 2019. This is to compare the pattern of debris movement. We simulated every month for 1 year, so the simulation is continuous. It's continue from the last point every month. For trajectory particle model, we use Eulerian method. It means it's only show the macro debris position at the last time. It doesn't show the debris movement every time. And this is a result of when in 1999, the average wind velocity range from 0.3 to 2.7 meter per second with dominant direction from northeast and southwest. The maximum velocity is up to 2.7 meter per second move from the northeast. And then in 2019, the average wind velocity range from 0.3 to 2.4 meter per second with dominant direction from southwest, and the maximum velocity is up to 2.4 meter per second move from the northeast. The decreasing of wind speed in 2019 because topography and construction in Jakarta changed. Sofian said in 2010, loss of mountain and contraction of tall buildings can decrease wind speed. This is result of tidal. Jakarta Bay has a diurnal type with from the value 3.5. It means there are one flood tide and one ebb tide in one day. The seasonal tidal pattern show the same pattern in 1999 and 2019. In west season, flood tide occurs at 12 to 3 o'clock, and ebb tide occurs at 6 to 12 o'clock. But in ICZM, flood tide occurs at 6 until 12 o'clock, and ebb tide occurs at 18 to 6 o'clock. This is result of verification data. Wind model data from ICMWF has a good accuracy, especially in the tropic. So the data not need verification data again. Bathymetry and coastline Data are obtained from the hydros by direct measurement, so no weather verification is needed. Tidal data from prediction tidal height of Mike will be verified by root mean square error method using tidal data from IOC level monitoring in Colonial 2 Jakarta Station and disease coordinate of station. The error value average is 2.07%, with the accuracy value is 97.93%. When RMSA value closer to 0, the prediction result will be more accurate. This is current pattern in 1999 and this is current pattern in 2019. Jakarta Bay has a tidal current pattern. In 1999, the average velocity ranged from 0.015 to 0.3075 meter per second, with the flood tide current range from 0.025 to 0.3075 meter per second, and ebb tide velocity current range from 0.015 to 0.225 meter per second. And this is value of the wind velocity range in 2019 and the flood tide current range and ebb tide current range velocity in 2019. And this part show the macro debris movement pattern. The macro debris track in 1999 looks more complicated and longer than in 2019 because the wind speed and current speed in 2019 were slower than in 1999. In 2019, the ebb tide current rate reached up to 0.165 meter per second. Meanwhile, in 1999, the ebb tide current reached up to 0.225 meter per second. Ebb tide currents are currents that carry debris away from the source, so that the smaller the ebb tide current, the slower the movement of debris away from the source. And this part, we will discuss analysis movement pattern to define accumulation debris area from every source, so we can determine the potential source of macro debris in Untung Java Island. First is Citarum. Debris from Citarum carried out to south and will be accumulation in yellow box area. And then debris from Cikeas carried out to south and will be accumulation in blue box area. Debris from Ciliwung carried out to northwest, and this is pier. The pier will block the movement of macro debris, so macro debris will accumulation in this green box area. Debris from Muara Angke or Angke Azuares carried out to northwest. In the end, will be accumulation in Untung Java Island. Because if we see the pattern of currents, current in Jakarta Bay move to northeast and then north. Debris from Cisadane carried out to north and northeast, so will be accumulation in Untung Java Island. When viewed from the pattern of movement, the Cisadane estuaries and Angke estuaries is a potential source as a contributor of debris to Untung Java Island. But Cisadane estuaries is the most potential source because Cisadane estuaries close distinct to Untung Java Island and the pattern of debris movement closer to Untung Java Island. The last part is conclusion. The finding exhibit that Angke and Cisadane are source of debris supply to Untung Java Island, And the second is Cisadane estuary is the most potential source as a supplier of macro debris to Untung Java Island because its debris movement pattern and the nearest distance to the island. And this is reference for our research. That's all from me. Thank you for your attention. Bye-bye.
Okay, thank you very much. I think we can move to for question and answer. So anyone who has questions, please directly unmute your.
Hello, everyone.
Yeah, start again. Okay, please, if anyone has questions, we have 2 minutes for question and answer for discussions. Is there anyone who wants to give questions? I think, yeah. Miss Adinda Maharani is present here, so she can directly answer your questions. So please, if you have any questions. If there is no, then I have one question. Miss Adinda, are you there?
Yes, I'm here, Mr. Tato.
Thank you very much. So I'm a bit curious and also a bit confused with the verifications of data verifications that you already present. So what do you mean with data verifications then? Because what I get from your presentations is you haven't verified your simulation results. And what is the meaning with the data verification in your study, actually?
Okay, thank you, Mr. Latok, for your question. Can I answer with bahasa?
Yes, I think.
I'm sorry, Mister. Jadi Pak, sebenarnya saya memang tidak melakukan verifikasi simulasi setelah dimodelkan, tapi saya melakukan verifikasi data sebelum data itu digunakan sebagai data model, gitu Pak. Jadi saya melakukan verifikasi data-data untuk diverifikasi apakah data yang saya pakai itu merupakan data yang akurat untuk dijadikan data mentah untuk disimulasikan, begitu Pak.
Okay, thank you very much. Probably I need to translate a little bit. So actually, Miss Adinda Maharani already tried to validate her data in the study, but she hasn't validated the simulation results. Probably for the next time, she will validate his modeling results. I think that's all. And if anyone has any questions, please. If there is no, then we move to the next presenter.
Pak Toto, sorry, I think there's one question from Najib in the chat room.
Okay. Chat room. Okay.
So, yeah.
From Najib Habibi. So there is a question for Ms. Adinda. The question is the model also predict the volume of macro debris beside the tracking of their movement?
Yes, you can. If you use Mike 21 and you input volume or fluke in macro debris, you can predict the volume of macro debris. But in this simulation, I don't input volume of macro debris.
Okay, thank you very much. Mr. Najib Habibi, if you have any questions, you can directly ask or others. If no, then we move to the next presenters because time is already running out. Okay.
Okay, thank you, Mr.
Thank you. Okay, next presenter will be, yeah, it's already in my monitor. Mr. Edwin Apriyanta. Actually, yeah. You will present by video or live? I think video.
Yes, I will present the video. Maybe the computer will play it for me.
Yes. Yes, thank you. Please, committee. Yes, we need to wait 4 minutes.
Good afternoon, everyone. My name is Edwin Winardi. Here, I would like to explain about our research entitled Modeling of Plastic Debris Particle Trajectory during pre- and post-reclamation in Jakarta Bay.
Okay.
Introduction. The environmental problems that we can find in Jakarta Bay are litter and reclamation. In front of you, there is a map of Jakarta Bay, which border to the most populous province in Indonesia, the province of Jakarta. Human activity that do not escape the litter produce, and improper handling of litter are bad combination that result in litter that can end up in the sea. The red image show the accumulation of litter in the mangrove ecotourism area of Angkesdori and in the Cilincing area. Previous studies have stated that the litter in Jakarta Bay is dominated by plastic litter. Reclamation activity also have an impact on the hydrodynamic condition of the Jakarta Bay. Until 2015, there have been 3 of the 70 reclamation islands planned. The 3 islands named C, D, and G Island. After the government decree numbers 74 and 44/2018, the 3 islands were named Kita, Bisa, Bersama, and Bersama coastal area. The impact of reclamation on distribution plastic waste is our goal of this research. The research method was carried out in 2 stages. The first stage is hydrodynamic simulation, and the second stage is plastic trajectory simulation. The hydrodynamic simulation used 2 conditions: pre-reclamation and post-reclamation, which shows in front of you bathymetry of Jakarta Bay in 2006 and in 2015. There is the 3 scenarios shown in the table on the right. The simulation were carried out on June to see the effect of east monsoon, and the third scenario in the December to see the effect of the west monsoon. Hydrodynamic simulation results were verified by calculating the RMSE and correlation between the simulation result elevation and tidal prediction from the Geospatial Information Agency. RMSE calculation is carried out in the middle of the day, and the red cross indicates the location. Current verification by comparing the simulation result with the current data obtained using ADCP. Measurement location are around about Bidadari Island, or this shown in the red plus sign. The trajectory simulation has the same domain as the hydrodynamic simulation. The figure and the table show the coordinate location of the plastic release at the beginning of the simulation. The total weight of the plastic in the table is assumed to be particles, where 1.0 tons of litter is 1 particle. In this simulation, it is assumed that the particle have a lower density than a seawater. Then the particles are conservative, and the particles are only affected by the advection. Result. Verification of tidal elevation simulation result with the tidal prediction is shown in the image above. The figure shows the simulation result has the same tidal range and tidal pace as the BIG tidal prediction. RMSE worth about 7 to 8 centimeter has a minimal value compared to the tidal range about 1 meter. The correlation between two values shows a correlation about 95%. Positive correlation and a value, RMSE value and correlation value is close to 1%, 100% or 1 indicates that the two variables are interrelated and in the same direction and have a solid relationship. The comparison between simulation current and ADCP current shows in the figure below. The two data shows the direction of movement around the island Bidadari. Based on the verification that has been carried out, it can be stated that hydrodynamic simulation has been able to describe the tidal condition and hydrodynamic condition in Jakarta Bay. The average elevation and currents, ocean currents of Jakarta Bay are shown in the figure above. The ocean current in the first scenario has a small speed than the current in the scenario, the second and the third scenario. It shows us that the wind factor affects the currents in the Jakarta Bay more than the tides. The three scenarios shows a decrease in current speeds, especially around the reclamation island. In the first scenario, the decrease is about 0.002 meter per second, and the second and the third scenario, the decrease speed is about 0.03 to 0.05 meter per second. Change in the current patterns occurs only around the reclamation island. Change in the current patterns and decreasing speeds are the evidence of the impact of the reclamation island on the hydrodynamic condition in the Jakarta Bay. Okay, the trajectory simulation of the first scenario shows the distribution of plastic debris eastwards from the initial point of the released particle. The cause of the eastward distribution is due to the tidal asymmetry, where the tide period is about 8 to 15 hours a day, and the ocean current enters the bay at the flood tides and move relative to the eastward. Reclamation island impacts to the shorter particle millage in post-reclamation condition. You can see in the table 3 where the average particle displacement at 2015 was shorter than the pre-reclamation condition. The second scenario shows the pre-reclamation coast area traversed by the released particle. It's also seen that particles are moving in the canal formed by the reclamation island. The canal is have 1.0 to 1.3 kilometer width. The simulation result shows the presence of particles that came out of Jakarta Bay, especially in the second and the third scenario. About 94% and 70% of plastic left Jakarta Bay in June 2006 and June 2015, and about 74% and 70% particle was released in Jakarta Bay is left in December 2006 and December 2015. The trajectory simulation shows that plastic debris take a longer time in the post-reclamation. You can see in table 4, which is average time requires in hour for plastic debris particle leave the Jakarta Bay. The increase of percentage of plastic debris at the end of the simulation and the longer of time required for particle to leave the domain are evidence of the impact of the reclamation on island on the distribution of plastic debris in Jakarta Bay. Reclamation island acts as a litter trap, evidenced by the accumulation of litter around the island. Trajectory shows the presence of particles passing through the canal. In actual condition, there is possibility of plastic waste standard along the coast. The conclusion that can be drawn are distribution of plastic debris is moved according to the season, eastward in the west monsoon and vice versa. Influence of the reclamation island. The first is the increase of percentage plastic debris post reclamation. Second is longer time requires to plastic debris leave the Jakarta Bay. Impacts in the accumulation of plastic debris in the Jakarta Bay. The two things above is caused by decreased speed ocean current due to the reclamation island. A threat for the accumulation of plastic debris in the canal between the reclamation island. There is a threat. So, waste management in Jakarta Bay should be cleaned regularly, especially in the reclamation island area. So that's all I can say. Thank you very much.
Yes, thank you very much. So I think we arrive at the Q&A sessions. Is there any questions for Mr. Edwin Apriyanta? Please just unmuted your mic, speakers, and then you can go directly deliver your questions.
Can I ask a question?
Yes, please.
Thank you. My name is Deviona, and I would like to ask, with this movement modeling of the plastic debris, is there any type of plastic that we can decide the movement, or is that like for your model, is any type of plastic, or is there any specific type of plastic debris? Thank you.
Mr. Toto,
yes, you can directly answer.
Okay, thank you for the question. For my simulation, saya jawab dalam bahasa Indonesia dulu ya. Dalam simulasi ini, saya tidak mendefinisikan jenis plastik yang saya gunakan dalam simulasi. Dalam simulasi ini, saya hanya menggunakan satu jenis, menganggap semua plastik yang saya lepaskan itu sebagai plastik yang uniform. Tapi dengan asumsi plastik ini memiliki densitas yang lebih rendah daripada air laut. Terima kasih.
Will you translate it in English? Study? Because it's international conference.
Okay, sorry.
Please try.
In this simulation, I was not clarify which plastic I use, but I assume that plastic that I use is less denser than seawater. So maybe in the next research, I will classify the plastic that I use in the trajectory simulation. Thank you.
Thank you very much. I think, is there anyone has a questions? Please, we still have 1 minute for QA sessions. Yeah, 1 minute. I think if there is no, then we can move to the next presenters.
Yeah.
There is no questions. Okay. Okay, let's move to the next presentations. It's also a video. Please. The next presentation actually is, yes, okay. Is it? Yeah. Yeah, the next presenters will be Miss Devi Yona. This topic is about microplastics contaminations in interbreeds. Yeah, yeah, please.
Good morning, ladies and gentlemen. Allow me to introduce myself. My name is Anwar Rizal from Marine Research Center. And
oh, yes. Yes, please. Sorry, I was mistake. Actually, the next presenters will be Mr. Anwar Rizal.
Ladies and gentlemen, allow me to introduce myself. My name is Anwar Rizal from Marine Research Center. And today I will represent our team to present forecasting the stranded area of marine debris in Indonesia coast. An initial result of simulating the seasonal pattern of marine debris by tracking the floating drifter. In this research, we collaborate with other researchers from other institutions, such as from World Bank, from IRD, from CLS, and also from internally from KKP. As we all know that Indonesia has more than 17,000 islands, and the majority of its territory is an ocean. The table above shows that Indonesia has biodiversity such as mangrove, coral reef, fish, seagrass, and many other diversities that come from the ocean. Good morning, ladies and gentlemen. Allow me to introduce myself. My name is Anwar Rizal from Marine Research Center. Good morning, ladies and gentlemen. Allow me to introduce myself. My name is Anwar Rizal from Marine Research Center. And today I will represent our team to present forecasting the stranded area of marine debris in Indonesia coast. An initial result of simulating the seasonal pattern of marine debris by tracking the floating drifter. In this research, we collaborate with other researchers from other institutions, such as from World Bank, from IRD, from CLS, and also from internally from KKP. As we all know that Indonesia has more than 17,000 islands, and the majority of its territory is an ocean. The table above shows that Indonesia has biodiversity such as mangrove, coral reef, fish, seagrass, and many other diversities that come from the ocean. However, plastic waste from the land base and from the fishing activity threat to marine ecosystem and marine biota. Responding to issue related to marine debris, the Marine Research Center has conducted several studies on marine debris, including the study conducted in the Jakarta Bay that show in the live, and then study conducted in Bali Strait in the middle of the picture, and the last one is in Banten Bay. This study conducted locally around the Java and Bali Island. Results indicate that marine debris are moving away from the origin and drift by wind and current from time to time. These are only local-based simulation and centralized around Java Island. Result of this simulation will forecast the time and place where the marine debris is going to traverse and will be built up in each season. This will useful for planning the mitigation and action to address marine debris in region with more efficient and effective. In 2020, Marine Research Center collaborate with other institutions such as Coordinating Ministry of Maritime and Investment, Ministry of Environment and Forestry, World Bank, CLS, AFD, and IRD. In this project, we released around 20 drifter in 3 major rivers in Indonesia, which is Cisadane, Bengawan Solo, and Musi. And through this project, hopefully we can improve our understanding of marine debris movement and its distribution in Indonesia seas, in order to optimize the action plan and encouraging further marine debris research in certain area in Indonesia. First release we done in February 2020 in Cisadane River. And as you can see in the picture, one of the 3 of the drifter that are released in Cisadane is moving to the west, the Indian Ocean. And this project can improve our understanding, as I said before, that we can improve our understanding of marine debris movement and its distribution pattern at seas in order to optimize the action plan and encouraging further suitable marine debris research in certain area in Indonesia. Yes, as I stated before, the objective of the research to improve the understanding of the marine debris movement and its distribution. And in this research, there are several methods that we use. First is the drifter, MARGT drifter. We assume that this drifter is the marine debris and can float in the sea. This made by the CLS. The weight of the drifter is around 1 kilogram. The length is about 28 centimeter. And this water resistant, certified by IP67. Satellite system as Argos integrated, GPS, telemetry Argos, and the batteries can live to 12 months. And then we also use Mobi Drift client that provide an interface to combine multiple data such as drifter simulation, Argos-based transmitter location, and meta-ocean data. This application allow us to create drifting simulation, monitor drifter, which were deployed at various locations and analyze their movement. We also deployed 20 drifter released in 3 major rivers in Indonesia, which is, as said before, Cisadane, Bengawan Solo, and Musi. This is the current position of tracking drifter released from Cisadane, Bengawan Solo, and Musi. Most of the drifters circulate in Indonesia and then also back to the Indonesia beach. And some of them escape to the Indian Ocean, and one drifter is landed in, I think, Tanzania, Africa, after 1 year. This more specific, the drifter released on 7 February 2020 from Cisadane River, and the position, this the position in August 2020, moving eastern to past the strait between Bali and Nusa Tenggara, and then going downward to below the Christmas Island, and then move to the around the Cocos Island. On 16 July 2020, we released another drifter from Cisadane. Two drifter landed in Lampung around the Semangka Bay, and one drifter landed in around the Angkano Island. And then the two drifter is moving to the Indian Ocean. This also the last position in around August 2020. This is the drifter release in Bengawan Solo. 5 drifter released from this river, and around August, the position of the drifter is in the eastern of Lampung. Some of them landed in the Lampung beach, and the other is moving downward to the Indian Ocean through the Sunda Strait. On 23rd July 2020, 5 drifters also released in Musi River in Palembang. However, most of the drifter is landed back to the land, and only one drifter is moving upward along the Jambi coast. Based on the initial result of the project, most of the drifter released in Indonesia River are back to the beach, and only few drifter are stay on the seas. This result is in line with the model that developed by IRD and AFD that state around 60% of marine debris particles are back to the beach, and around 40% of them stay on the seas. And through this project, hopefully can encourage other marine debris research, especially in this research in the small island and deep sea zone in Indonesia. And hence, this requires a good cooperation across sector in local, regional, national, and international level. That's what I can present today, and hopefully I can have some input and or comment or question from this presentation. Thank you.
Yeah, thank you very much. I think it's very interesting study. There is one question in the chat board, so I will read. Yeah, this is a question comes from Miss Enki Krishnarti. The question is, does the drifter continue to exist on the sea surface or up and down at a certain depth of the sea? Thank you. Yes.
Thank you, Pak Toto. I have answered the question through message to Ms. Anggi, but I will explain that the drifter is stay on the sea surface, and every 3 hours the drifter is transmit data to satellite, and we can
I would
monitor
like to
the
present my research on my
drift every hour. So the position of each hour is recorded in our data.
Yes, thank you very much. Is there any other questions, please?
May I, Pak, Mr. Toto?
Yes, yes, please.
Yeah, it's quite interesting research that so that we can see the movement of the marine debris, and I'm interested in especially in the drifter from the Cisadane River that ended in the Indian Ocean. May I know how long the drifter movement from the Cisadane into the Indian Ocean? Because yeah, I didn't see the duration of the duration of the drifter from the Cisadane into the Indian Ocean, and also yeah, just first question. Yeah.
Yes.
Can you see my screen?
Yes, yes.
Yes. So I will show this slide. So this drifter is released in February 2020, and this data is around July. It's around 6 months. The drifter is moving to the Indian Ocean, and we're still developing this portal, and hopefully we can next we can show you the full track of this drifter that moving to the Indian Ocean and landed to the Tanzania, because one drifter that we released from Cisadane is now in around Tanzania in Africa.
Oh, okay. Yeah, it take 1 year.
Yes, yes, it's almost 1 year. This the current data is last 2nd of August. Last week I record this.
Okay. May I ask one more, Mr.
Yes,
Toto, or
please.
is it? Yeah.
Yeah, actually, I'm sorry running out, but it's okay, Pani.
Okay. Yeah, based on the movement of the drifter, is there any correlation? I mean, have you been correlate between the drifter with the hydrodynamic pattern in the Indonesia seas? Because I saw in the orange pattern that in the suddenly that first it's moved into the
yes,
first move into the east, but and then going to west again. Is there any correlation with the current pattern? Yeah.
Yes, and this is the we have like correlation with the west monsoon and east monsoon that in Indonesia, identical in Indonesia, and we assume that this we also developed the model for this drifter movement, and so when we with the pattern in Indonesia, we think that this is very similar with the season in Indonesia, that during the west monsoon it's going to the east, and during the eastern monsoon it's moving back to the west. And in the portal that we still develop, we will also include the modeling in our portal, so we can predict on the moving of the debris that come from the river in Indonesia. And through this project we also will developing again and release more drifter around 50 drifter in, and we will spread in maybe each river in most major island in Indonesia like Kalimantan, Sulawesi, and other islands. So we can gather more data and information related to the movement of this drifter.
Okay, thank you, Mr. Anwar.
Thank you very much. So actually, there are several questions in the chat boards, so please answer it by.
Thank you. I will answer the question in chat box.
Yes, thank you very much. Yeah,
thank you,
I think your study is very interesting. And we should move to the next presenters. Ms. Yona. So, please.
I would like to present my research on micro.
So you'll present not directly.
I would like to present my research on microplastic contamination in invertebrates from my. I would like to present my research on microplastic contamination in invertebrates from mangrove forests of Probolinggo, East Java, presented by myself, Devriona, with my team Sabayu Krisnahadi, Aida Sartimbul, and Arif Zainul Fuad. We all from Marine Science Department, Fisheries and Marine Science Faculty, Universitas Brawijaya, Malang. I will start this presentation with introduction. Microplastic has been the subject of many studies worldwide. It has been considered as one pollutant with significant impact on the marine environment. Most of microplastic in the aquatic environment is the result of the fragmentation of bigger-sized plastic waste due to the exposure of sunlight and water movement. With their small size, it can be found in abundant number in the seawater and accumulated in the sediment and bottom of the ocean. Once in the aquatic environment, microplastic has the potential to be absorbed by marine organisms through respiration and digestion process. Many studies have found the accumulation of microplastic in wide range organisms, from the small-sized plankton, bottom organisms such as crabs, mollusks, annelids, and also fishes. Mangroves are highly susceptible to debris since they are ecosystems that lies between land and sea. In addition, the spatial complexity characteristic of mangrove ecosystem provides many opportunities for debris to become entangled and eventually enhances their role as sinks for plastic pollution. Microplastic pollution has also been subjected to the study in mangrove ecosystems. Mangrove forests host diverse and highly specialized invertebrate fauna. Invertebrates play critical roles in mangrove ecosystem. It helps maintaining nutrient cycling, filtration, and also in biochemical processes in the ecosystem. It is very important to investigate the presence of microplastic in this small organism. Therefore, the goal of this study is to analyze the occurrence of microplastic in 3 different invertebrates in the mangrove ecosystem, which are gastropod, Telescopium telescopium, bivalve, Isocnomon, and mud crab, Scylla serrata. In this slide, I would like to explain the characteristic of each invertebrate species in the mangrove ecosystem. I will start with the Telescopium telescopium. Telescopium telescopium is found in shady places in the more exposed part of mangrove areas. It grazes on decomposing fallen leaves and also consumes the mud, mainly formed by mangrove litter. It also actives only when exposed by low tide, withdrawing into its shell whenever covered with water. And the next one is Isocnomon isocnomon. It is the most numerous and common bivalve found in mangroves. It forms small cluster of at least 2 individuals attached together to mangrove roots. And the next one is Scylla serrata. It is a widespread species in estuarine and mangrove habitats in the Indo-Pacific region. Mud crabs are top benthic predator, and parents, sessile or slow-moving benthic macroinvertebrates, mainly gastropods, crustaceans, and mollusks. This study was conducted in mangrove ecosystem of Mayangan, Probolinggo, Jawa Timur. It is a small ecosystem with coverage area of 48.46 hectares. It receives significant amount of pollution from anthropogenic activities such as industrial, domestic, and fisheries. In this study, there were 3 sampling locations. Sampling was conducted on February 2021. 15 individuals for each species were collected and in total there were 45 invertebrate samples to analyze. In the laboratory, each sample was measured its body length in centimeter and weight in gram. After morphometric measurement, the sample was dissected to retrieve its soft tissue. The soft tissue was then weighed for the wet weight in gram. Digestion process was conducted to destroy organic matter using hydrogen peroxide solution. The samples were then filtered to separate microplastic particles and identify the type of microplastic using microscope. Results. Microplastic were observed in 15 individuals of each invertebrate, and out of 45 samples, only 12 samples were found without microplastic in its soft tissues. It means 73% of the samples contain microplastic. Microplastic were counted in almost similar number in each organism, with the average of 2.7 particle per individual for Scylla serrata, 2.3 particle per individual for Telescopium telescopium, and 2.1 particle per individual for Isocnomon. Between species, smaller size organisms contain more microplastic than the bigger size one, as we can see in the next slide. We calculated the amount of microplastic in 2 types of units, which are particle per individual and particle per soft tissue weight. The results show 2 different patterns. According to the number of particles per individual species, microplastic was the highest in Scylla serrata, followed by Telescopium telescopium, and the lowest was in Isocnomon isocnomon. Meanwhile, when the number of microplastic particles were calculated based on the species soft tissue's weight, the results show that microplastic were the highest in Isocnomon isocnomon, followed by Telescopium telescopium, and very low number of particles of microplastic in Scylla serrata. Until now, there is still no agreement in which units should be used to calculate microplastic abundance in organisms. According to the percentage of microplastic found, fiber were the most common type of microplastic found in each species, while fragments and film were less commonly observed. And in detail, we can see that fiber and film were found in Telescopium telescopium, while fiber and fragment were found in Scylla serrata. 3 types of microplastic were identified in Isocnomon isocnomon. Fiber have been known to be the dominating type of microplastic in aquatic environments as the result of anthropogenic activities. Mostly, it originates from clothes and also fishing gear such as net. The conclusion of this study is the uptake of microplastic in the organism is the result of respiration process and dietary input. The presence of microplastic in mangrove ecosystem in mangrove organism is related to species type, morphometry, such as body length and weight, feeding habits, microplastic in the mangrove environment, that is in seawater and sediment, and lifestyle. Mud crab may limit their foraging activity and distance since they have to always come back to their burrow. This might be the reason between the species that Scylla serrata has the lowest microplastic content per gram soft tissue. Moreover, Scylla serrata can be considered a selective species regarding its food type, since it preys on slow-moving invertebrates. The studies of microplastic in fish have shown that predatory species contain less microplastic than the filter feeder and deposit feeder fish. On the other hand, high number of microplastic in Isocnomon may be the result of its slow movement. Isocnomon is typically attached to mangrove roots or larger stones covered with silt of the muddy environment, and low water exchange rate and high usage of plastic increase the probability of microplastic being ingested by these organisms. Acknowledgement. This study was conducted with the funding from Program Penelitian Guru Besar dan Doktor tahun 2021, Fakultas Perikanan dan Ilmu Kelautan Universitas Brawijaya. We thank Billy Arlif Mahendra and Gibran Aji Basutikto for their help during sampling and laboratory analysis. Thank you.
Yes, thank you very much. We arrive at the QA sessions. Is there any questions? Please directly. Yes.
Good day, everyone. My name is Hanif Tiastomo. Today, I would like to present my preliminary research about marine debris tracking from river discharge based on hydrodynamic simulation on Jakarta Bay.
I would like to present my
Sorry.
Good day, everyone. My name is Hanif Tiastomo. Today, I would like to present my preliminary research about marine debris tracking from river discharge.
I have a question.
I would like to
Yes,
present my research
Yeah,
on
so I
microplastic
have read that
contamination
it
in
is
invertebrates
actually
from mangrove forests
difficult
of
to do the
Pulau Bengkok,
microplastic
East Java.
analysis
Defended by
because
myself,
there's a high
Deviona,
possibility
with my
that you will
team
get a
Sambayu
background
Krishna Hadi,
contamination,
Aida
whether from the
Satrio,
sampling
and
from
Farid
the
Zainul. We all
site
from
or
Marine
sampling in the
Science Department,
laboratory
Fisheries and
analysis,
Marine Science
etc.
Faculty,
And
Universitas Brawijaya,
my question is,
Palembang.
do you consider that this
I will start this
that
presentation with
you will have a background
introduction.
contamination, and did you
Microplastic
have
has been the
some
subject of
strict
many
protocols
studies
to
worldwide.
prevent this
It has been
contamination?
considered
And
as
my
highly
second question
pollutant
is,
with
I see
significant
that you only validate the
Good day,
microplastic
everyone. My name is Hanif
in the
Tiastomo. Today, I
organism
would like to
through
present my preliminary research
microscope.
about
But I
marine
think
debris
it's
tracking
difficult to know
from
that
river discharge
the
based on
particle that we have,
hydrodynamic
it's
simulation on
truly
Jakarta Bay.
polymer
Yeah,
only
this
by
is
microscope. So
another
maybe my
researchers
suggestion
that also
in the future,
contribute
maybe you should also
in this
consider
research.
another technique to validate the
Yeah.
microplastic,
First
maybe by
of
using
all,
the
we
FTIR
need to know
to
what is the
sure
marine
that
debris.
the
Marine
particle
debris
that you
is
have is
defined as the
polymer.
persistent solid material that manufactured or
Thank you.
processed
I will
Miss
directly or
Debriona, sorry.
indirectly.
Before answering the questions, I cannot recognize the who already send the questions actually. Please mention your name.
Oh, my
and
name
your
is
institution.
Dwi Amanda Utami.
Okay. Yes, thank you. Please, Mr. Deviona.
Okay, thank you, Ms. Dwi, for the questions. Yeah, regarding with the contamination, it's always a problem during the analysis of microplastic because we know that microplastic is everywhere actually. So the most common contamination is the fiber from the airborne fiber, and it's not really easy to avoid that contamination, but we try our best to make our sample is as clean as possible. I mean, but it's not really easy. I know it's not really easy. So during the laboratory analysis, especially, we try to always make sure that we have, for example, for the airborne fiber, we try to put the easiest one is we try to put kind of sellotape to know that if there is a airborne fiber, and then we always try to make sure that our sample is always in a close position if we are not using it. But yeah, we know that contamination we cannot really avoid it, but we try our best to reduce it. And then with the analysis, yes, I know this is also like our preliminary study. Actually, we have the study not only in the organism, but also in the seawater and in sediment. And then with the organism, especially if we try to identify microplastic in a very small organism, this is like a challenge to make sure that we can have the samples to analyze in FTIR because it's really very small. And at this moment is we try our best to identify the type of the microplastic using microscope that we have the requirement to identify it. Like, so, for example, if the colors is like really clear, a blue for fiber, it looks like a fiber, and then blue and red from the microscope, and we can consider it as a microplastic. But yeah, we know that we need to make sure the polymer of the microplastic using FTIR. But due to the very small size, it's not really easy, but we will try with our sample from the seawater and also sediment. Hopefully that we can get a bigger size of microplastic to be analyzed using FTIR. I hope it's answered your question, and thank you very much for the suggestion.
Yeah,
Thank you very much.
It's clear. Thank you.
Yeah, thank you very much. I think the time has been running out.
Thank you.
So we should move to the next presenter. Yeah, I know this is also an interesting study. So I hope that there will be also good discussion next outside of this room, I think. And please, the committee, I think we should move to the next presenters. Mr. Hanif Tiastomo, the next presenters.
Yeah. Good day, everyone. My name is Hanif Tiastomo. Today, I would like to present my preliminary research about marine debris tracking from river discharge based on hydrodynamic simulation on Jakarta Bay. Yeah, this is another researchers that also contribute in this research. Yeah, first of all, we need to know what is the marine debris. Marine debris is defined as the persistent solid material that manufactured or processed directly or indirectly and disposed into water mass. The water mass may as ocean, a river, or lake. The existence of marine debris is very harmful to any living organism and environment. And as we know, the majority of marine debris, especially in the ocean, is plastic waste. So that in this research, my research mainly focus in the plastic waste. Yeah, based on the past research, in 2015, Jambeck found that in the 5 years from 2015, the plastic waste will increase about 6.4 million tons in the world. As Indonesia is the second biggest plastic waste producer in the world, it will contribute to increasing the marine debris about 0.48 until 1.29 million metric ton per year. Yeah, because Java Island is part of Indonesia, the Java Island is the biggest marine debris producer based on the research of Willoughby in the 1997. Yeah, the biggest marine producer in Indonesia because the Java Island has densest population in Indonesia and also has have a lot of rivers that end into the oceans. The information also from the Environmental Agency in Jakarta in 2016, with the population of 30 million people in Jakarta city, it will produce solid waste about 6,000 until 7,000 ton daily, and estimated about 10% of that total waste, about 600 until 700 tons a day, will be transported into Jakarta Bay because it mismanagement or poorly processed. So that's why several tons of the plastic waste will be transported through the river, or maybe people just throw it away into the Jakarta Bay. Yeah. Also in the 2019, the research from Cordova found that they are do the field survey to estimate the plastic waste around the river mouth of in the river mouth that end into Jakarta Bay, and they found about 8.32 ton plastic debris is accumulated in the Jakarta Bay. It's about 8 until 60 times larger than global model estimation. Another part that also important that also happened in Jakarta Bay is also the construction of the giant seawall. The giant seawall is part of the NCICD, or National Capital Integrated Coastal Development, that aim to protect the Jakarta city from floods. As we know that the Jakarta has a very dangerous flood that happen yearly, that happen annually, because the land subsidence, especially in the north of Jakarta, and also the global warming increasing the water level. This project included the construction of giant seawall that we can see in the pictures, in the right pictures. This is the scheme of the total of the NCICD project, and also the project is included in the 3 phase, and also the groundbreaking start from the 2014. Coming into the main research, that in this research we are using the numerical model to simulate the hydrodynamic condition in the Jakarta Bay with the two scenario. And the first scenario is we simulated using the we simulated the hydrodynamic condition in Jakarta Bay with the giant seawall, and the second is without the giant seawall. So we will know the differences of the hydrodynamic condition with and without the giant seawall. The model that we use is the FVCOM. It stands of the finite volume coastal ocean model to simulate the hydrodynamic. This model was developed by Surya in 2015. Because this is only the preliminary research, we only simulate from the 3rd until 19 July 2015. And for the first is hydrodynamic simulation. The FVCOM model using the basic equation, that is continuity and momentum equation. And we can see here in the equation, the first equation is the continuity equation, and the 2, 3rd, and 4th is the momentum equation in the X, Y, and Z. After we do the hydrodynamic simulation, and then we also run the trajectory simulation. The trajectory simulation is based on the Lagrangian particle tracking sim with nonlinear system based on the ordinary differential equation. So this is the equation that we use in the FECOM module for the trajectory simulation. Yeah, the results show that from the hydrodynamic simulation, we found that there's a quite huge difference from the float and ebb time. The water level tend to have similar water levels, but during the ebb time, in the western side of the Jakarta, in the eastern side of Jakarta Bay, have a lower water level comparing to the eastern, western of Jakarta Bay. With the existing of the giant seawall, we can see the giant seawall disrupt the water hydrodynamic condition. As we can see here, the water level inside the pond area have a lower level comparing to the outside of the pond area. So the existing of the giant seawall has hugely impact the hydrodynamic condition. This also happened during the ebb times that we can see here in the eastern side. The effect of the giant seawall amplifying or increasing improving the water level difference, as we can see here's comparing with without the giant seawalls. There's a huge difference from the differences of the water level in the eastern side and the western side. Yeah, the disruption also happened in the current condition in the Jakarta Bay, as we can see here, because we run the simulation during the Indonesian East monsoon from June to August. The current condition, the current movement, the current direction move from east to west. So without the giant seawalls, without the giant seawalls, the Jakarta Bay have a uniform of current direction. But due to the giant seawall, the current direction and also the magnitude of the current will change because the giant seawall, as we can see here, the area around the giant seawall will not affected by the current condition. In here, outside the giant seawalls, the magnitude or the direction will change dramatically comparing to the simulation without the giant seawall. Yeah, we can see also the result of the marine debris movement. The giant seawall also affect the distance of the particle movement of the marine debris, and some of the marine debris will accumulate it around the artificial island, while the simulation without the marine debris, without the giant seawalls, the marine debris movement only move around the Jakarta coast. Yeah. For the conclusion, the hydrodynamic condition in Jakarta Bay is strongly affected by Indonesian monsoon season that derive the current direction. And the giant seawall will affect the pattern of hydrodynamic that change in the current direction and magnitude, as well as water level condition. Also, because the particle movement majorly derived by the hydrodynamic condition in ocean, the particle movement pattern will change also due to the existing giant seawall.
Is it? I think Pak Hanif can explain for the last conclusions.
Yes, sorry, Pak. Yeah, that was cut.
Yes, thank you very much. I think we arrive at the question and answer sessions.
Good day, everyone. My name is Hanif Giastomo. Today,
Yes. Is there any questions for Pak Hanif? Please, you can ask directly. So it's as announcements. So we still have 2 more presenters. I'm sorry, I already mentioned about 7 presenters in the session. Actually, will be 8 presenters. So 1 more, and 2 last presenters will deliver the presentations directly. I mean live. Before that, please, if you have any questions. Oh, I receive.
Can I
Is
ask
there
the
any
question?
questions for Pak Hanif? Yes, please.
Yes. Thank you for the interesting presentation, Pak Hanif. So I'm just want to ask a simple question. You said that the debris is going up to the north area of Jakarta. So is the debris also going up into the Thousand Island? And where is the end of the particle or end of the debris? Thank you.
yeah, thank you, Ibu Karina. Yeah, based on our, our research, because there's a limitation time for the running. We only run for 2 weeks from 3rd until 19 July 2015, so that we cannot estimate where is the end of the. I mean, we don't know exactly where the marine debris will end, or will end. Will end, because I think we need to have a longer simulation if we want to know where the marine debris will end or stranded. But based on the another presentation from from the previous presenter, the marine debris which drifted from the Jakarta Bay able to stranded into Thousand Island, and from the KKP drifter tracking, it may move into the Samudra Indian Ocean, or maybe in the Java Sea. But because our research doesn't complete the longer the simulation, we cannot estimate. But we cannot estimate where the end of the marine debris.
Yes, thank you very much. I hope the answer this Karina questions. So we still have 1 minute for question and answer. If still there is any questions, please. I think all of the presentation is related to the marine debris, and also there is interesting results, especially the tracking from KKP presenters, that marine debris can travel away from the Jakarta to the Indian Oceans. This is very interesting. Even the percentage is small. I think this is a challenge for the modelers to track using the modeling. If still there is any questions, please. Actually, I received.
I have one question, one short question.
Yes, please.
Pak Toto. Okay, just one short question for Pak Hanif regarding your simulation with giant seawall. Is it possible that due to giant seawall, the marine debris will stranded along the coast of Jakarta Bay, and then also trigger like sedimentation in that area. Thank you.
Yeah, thank you, Agus, for the question. Yeah, based on our short simulation for 2-week simulation, especially in the western side of the Jakarta Bay, because there's a lot of the artificial island that block the water movement, especially from the river mouth. So the marine debris that came from the river mouth mostly blocked or stranded in the artificial island. And because also the giant seawall, the hydrodynamic condition in the Jakarta Bay will disrupt or affect it majorly. So the current movement or the water level condition will change dramatically. And yeah, mostly the marine debris will be stranded in the artificial island or maybe in the around or the coastal Jakarta coast. And because because the marine debris accumulation, it may become a sedimentation because there's no because the equilibrium or the balancing of the because the hydrodynamic condition will change. So there may be a sediment.
Okay, thank you very much. I think time is already running out. Let's move to the next presenters. We will deliver in live, I mean directly. Miss Devi. Yes, please. Yeah. On my notice, Miss Devi Dwiyanti Suyon.
Okay. Thank you, Pak Moderator. I already sent the video to the committee. The committee received our video.
In my note, you will deliver the presentations directly, actually. But okay, let's wait.
Okay. Okay, thank you. But maybe I will turn on the video because my internet is unstable. So I'm for this inconvenience. So thank you. I will start our
okay, wait a minute. I will ask to the committee.
Okay. So this is our presentation. Can you see the file?
Yes.
Okay.
Yes, we can see it.
Thank you. Okay. Good afternoon, all. Thank you, Pak Moderator. Thank you all. On behalf of my team, I will sharing about the distribution of marine debris in Jakarta Bay and its implication to the coastal ecosystem. So our presentation consists of introduction, methodology, and result. As we know, marine debris become a big problem for Indonesia since Jambek et al. Published in 2015 about Indonesia considered as second biggest polluter of plastic to the world ocean. So Indonesia still have lack of data. So the Jambek published is it true or not? So we have to prove it, and Indonesia has to do a baseline research to support the Indonesian plastic waste management and to validate the Jambek data. So the result comprehensive data needed to support the action in reducing 70% of marine plastic debris by 2025, according to Presidential Decree number 83 in year 2018 that concerning the handling of marine debris. This is Jakarta Bay. As we know, Jakarta Bay is a coastal region stretches from the west to the east, encompassing 3 different provinces, Banten, DKI Jakarta, and West Java. Jakarta Bay plays an important role in the region, environment, and ecosystem management, and also has a strategic geographical function. But due to the complexity of activities surrounding Jakarta Bay, so Jakarta Bay now influenced by that activity, and now the condition is very highly environmental pressure, very polluted condition there. There are 13 rivers that end up in Jakarta Bay, and one river is Citarum. Citarum then end up in Jakarta Bay, and as we know, Citarum is known recently as one of the most polluted river globally, including plastic litter. So Muara Gembong is a coastal area at the eastern of Jakarta Bay. This is the Muara Gembong in Bekasi Regency. The condition is very degraded by human activities, especially ponds activities. And on the other hand, our government already has a priority program on Citarum watershed management, and already state in Presidential Decree number 15 in 2018 years. So the plastic waste that has accumulated in the mangrove ecosystem in Muara Gembong area threaten the lutung Java. Lutung Java is the endemic species in Muara Gembong. So the aim of this research is determine of marine plastic debris presence and analyze its impact on the coastal ecosystem in Muara Gembong, and hopefully it can be support data and information for baseline Indonesia marine plastic debris. This is our framework research. We do some collected sample from Muara Gembong, Bekasi, and then we try to identification the composition and try to identify the distribution of the marine debris surrounding the Muara Gembong estuary, and then identify the impact marine debris, especially plastic debris in ecosystem coastal in Muara Gembong and estuary waters. So hopefully the data that we got in this activity can be as an input for design of technology. The other activity in Muara Gembong, we also educate the community about how to handling the solid waste or the debris. The sampling location in Muara Gembong, in Pantai Bahagia Village and Pantai Sederhana Village. The sampling in mangrove ecosystem was done by line transect adapted from ecological method using quadrat transect method with a size of 50 centimeter squares, and then conducted systematically every 10 meters from the coastline towards to the sea, and then samples sorted based on the type, and the sample were clean, and we are trying to quantitate the number of the sample, and the parameters of the sample that we measure is the composition, and we are stated the composition by a percentage. And then the other parameter is calculated by amount of waste or debris per type per meter square. This is what we are doing in Muara Gembong estuary and ecosystem. We try to collect the debris from surface waters and from mangrove ecosystem in Muara Gembong, and also the sediment sample we try to collect also. After we collected the sample from estuary waters and mangrove ecosystem, we try to identify the type of the debris, and then we separated the debris or the sample based on the type, and we sort it and try to weight the sample. And the other activity, this is our team, one of our team, try to educate the community there how to separate the sample and how to handle the debris. So this is the condition of Muara Gembong estuary and mangrove in Muara Gembong. There are so many debris there, and potentially to high risk for biota in that ecosystem, and also threaten the lutung java as I mentioned before. So the result is debris composition that identified in Muara Gembong consists of 80% is organic, consists of several types of plastic and rubber, and 20% is organic, consists of wood and its derivative, fish and plant. And the highest composition in both villages is plastic, even in estuary area and mangrove ecosystem. And the debris composition in Pantai Bahagia village ranging from 62 until 81% is plastic and dominantly consists of sachet and food packets. And the composition of debris in Pantai Sederhana village ranging from 50 until 80% is plastic also, and dominantly by sachet and styrofoam. But the abundance and distribution, the macro debris in Pantai Sederhana village was higher than in Pantai Bahagia village. 15 types in Pantai Bahagia village and 14 types in Pantai Sederhana village already found. And the highest amount of marine debris found in mangrove ecosystem compared with estuary waters. The density of debris that is stranded or trapped in the mangrove ecosystem is higher than in floating waste. There was mass waste in mangrove ecosystem close to land or residential area. The code of P3 indicated the location surrounding the residential area. This is the P3 indicated close to the residential in Muara Gembong. So the amount of waste, especially plastic, that leaks into nature and trapped in the mangrove ecosystem, potentially to affect the existence of the mangrove ecosystem and the biota in the mangrove ecosystem or the cultivated biota, as we know in previous picture there. Some debris in Muara Gembong estuary and mangrove ecosystem. So the data that we got is debris in estuary waters about 0.128 grams per meter square, and debris in a river area in surrounding Muara Gembong is about 0.233 grams per meter square. And then debris in mangrove ecosystem is about 1,164 grams per meter square. So we can conclude that there are 5 categories out of 7 categories of marine debris found in Muara Gembong, and there are found also 25 types of waste from 41 marine debris type. there are more than 60% is plastic. And the second conclusion is more types of floating macro-sized garbage were found than in mangrove ecosystem, but the highest density is found in the mangrove ecosystem in the Pantai Bahagia village and Pantai Sederhana village. And then the third conclusion is the highest amount of macro debris in mangrove ecosystem due to the distribution of waste originating from rivers, Citarum rivers especially, and also carried by tidal waves and trapped surrounding Muara Gembong estuary. And then the last conclusion is the amount of waste entering Muara Gembong estuary through the Citarum rivers indicated that there are minutes of solid waste in upstream and downstream area. That's all our result. Thank you for your attention.
Yes, thank you very much, Dr. Devi. I think there is one question in the chat box. I think we need to go through very fast because time is already running out, but we have one last presenter. So the question is, could you differentiate between the marine debris comes from the river or come from the open oceans? That's the questions. Please answer it shortly. Dr. Devi?
Okay, thank you for the question from Pak Budi. Yeah, from the field that conducted we try to count the sample from the estuary, but we still cannot identify the source of the debris, which dominantly come from the river or the sea, because the debris also accumulated in the surrounding estuary and mangrove ecosystem. But if we saw the mangrove ecosystem, there are so many debris there, so we can conclude that dominantly the debris in mangrove ecosystem come from the land. That's our conclusion. Thank you. Hopefully it can be
yeah, you can have more discussions
yes, thank you.
later on. Yeah, and we should move to the last presenters, actually should be delivered by Dr. Novi, but on behalf of Dr. Novi, someone will present. Yes, please. Yes, Dr. Fajar, please. Time is yours. Yes, please. Sorry, I cannot hear.
Okay, thank you.
Yes, your voice is very.
Thank you. This is the same marine debris research is delivered directly. Let me introduce. I am Fajar Yudi Prabowo from Marine Research Center, Ministry of Maritime Affairs, the colleague of Dr. Devi and team, Dr. Agus Yawan. Started from the National Action Plan to Marine Debris Reductions to to reduce 70% of marine debris by 2025. Before this national action plan stated, there was a bombardment of from the Jambek and her team at 2015 that Indonesia is the second biggest country in the marine debris pollution. Then the fact is we are now in 2021. Means we have 4 years left to 2025 at the end of the national program. So what's the progress of the running program and how to improve the achievement of 70% marine debris reduction by 2025? This research is aimed to figure out the progress of the waste reduction, the existing waste reduction programs, and try to contribute the way to improve it. We have the mixed method, quality and quantity approachment with the primary and secondary data collection. And then the analysis were held before doing the comparative and entering the next stage, the scientific work. And the last was to finally constructing a conceptual model and the action plan recommendation. Here's the location of Jakarta City Water. It is inside the Jakarta Bay. So we use the local research conducted at 2019 by Cordova and Nurhati, which release the exact number of marine debris in Indonesia using the location Jakarta Bay. The research were held on 9 estuaries, which were 7 included in Jakarta administrative area, and 1 estuary in Tangerang, and 1 other in the eastern at Bekasi. So in this research, the choice of Jakarta City Water to become the pilot project of the research for reviewing and recommending the programs has some reasons. First, Jakarta is a capital city and densest population in the country, with also the highest growth of the industry, which means Jakarta and Tangerang and at the west and Bekasi at the east, and at the south it is Depok City and Bogor City. All of them, the neighboring cities, are the densest population in the area. All of them are the biggest producer of waste. And then while the waste entering the water, it becoming a marine debris. So the waste and marine debris in the water that flowing through the rivers on Jakarta Bay, and then finally emptying their content, their debris in Jakarta Bay water. So we can imagine the Jakarta Bay is a huge junkyard. So this location is the center of the discussion of the marine debris in Indonesia. Then
we lost your screen share.
Yes.
It's too short, I think.
Okay, I'm trying to share it, but there is a text that the host disable participant screen sharing.
Really?
Well,
So,
is it we are run out of time, but the number is still 40 minutes on the right side of
yes.
the monitor.
Yeah, it's wrong actually. We already passed 5, but okay. Pani, please help because I'm not the. Please open the share screen.
Yeah, I think the participant is still able to share screen. Can you try Pak Fajar to
Okay. Now, yeah, now,
yeah.
now. Thank you. Back to laptop. Here, the first work in this research is to review the data of the number of the marine debris, which the first we will compare the data of Jambeck et al. From 2015 research that host Indonesia in the second biggest waste producer in the world after China with 1.29 million tons per year. Most of research, even in the news, using Jambeck data, but not many of them, or not many of us, used the other data. We have here the local research result, which stated on 2019 that the number of marine debris in Indonesia is just half of the number of Jambeck et al. Data. So in this research, we prefer to use the data from the local researchers. And the next review is how much the weight of marine debris that already reduced. So in searching, we found some numbers from Ministry of Environment and Jakarta Province. That from the first statement of the National Waste Reduction 2018, and now at 2020, it has been 15% the reduction of the marine debris. Well, we don't know where the number coming from, but if we calculated prediction for 4 or 5 years on the future, which will be 2025, with the same rate of the reduction, we would have at 2025 estimatedly 30% of the waste reduction. The targeted program was 70%. So we have a slow progress. This is the data we noted. And the analysis from this research resulting 6 strategies to recommend it for improving the better progress in for the existing program. First, strengthening the waste reduction stage rather than the waste management. The waste management comprise of the socialization, education, regulation, but discussing about the reduction, we need the real and fast action. That's why we have chosen the to fortify, to strengthen the waste reduction, emphasize on technological use. And the next strategy is the direct program on site to be delivered. Next, third is the collaborative work and good coordination among stakeholders. The fourth, the comprehensive work, online-based ways and on-water-based ways, especially. The fifth, improving waste management program, both on land and on water. And the last, the sixth strategies, is the use of emerging technology. Here we recommend the multiplication of more 3R, reduce, reuse, recycle facility that is best established from the upstream zone and onto the downstream zone alongside the water body. Plus the development of more 3R facilities in each commune, especially in downstream zone at Jakarta. For your information, Jakarta has 267 communes, but ironically, Jakarta has only 4 units of 3R facility. That's irony. Of course, there are other 3R facility, but the private sector that's rolling them. We use example the success story from Bogor City. Bogor City has a smaller area and smaller amount of the people compared to Jakarta, but the Bogor City has 27 3R facility, and by now they are always add more 3R facility, and they have success story that all those 3R facility could reduce 16% of the waste.
Fajar, you have 1 minute left, please.
Okay, thank you. This is the technology use we propose, especially on water. So the focusing area in this research is it is better to synchronize the waste research reduction program with the flood management. So it is based especially on watershed. This is we pick the Ciliwung watershed as the biggest river, the dividing Jakarta to 2 parts in purple. That's in purple color, and those the yellow knots are the 9 estuaries, and up to north the ships, they are floating unit of 3R facility. So we propose here the small barge floating 3R facility. It has a function of the collecting marine debris on site on water. Also, it has a function to 3R, means this facility could reduce by burning the marine debris, and also could recycle them. Thank you.
Thank you very much, sir. And if there is questions, only one question, I think, because we're already running out. Is there any questions for Fajar? Please.
Which question?
Yes, please. If there is questions.
Oh yes, question.
So I'll check. So, yeah, there is a message that we should leave these breakout rooms in 10 seconds.
Oh my God.
So anyone, thank you very much. Pak Fajar, thank you very much.
Thank you, Mr.
So
Top.
we should close the session.
copyrights in Indonesia, B.J. Habibie as the third president, Iskandar Ali Shahbana as the father of the communication system in Indonesia.
Institut Teknologi Bandung is an adaptive learning organization. In our over 100-year journey, ITB has a long-standing as the leader in advancing science, technology, art, and social and humanities as well. ITB is striving to play a significant role in solving Indonesia's challenges while improving its capacity to compete globally. The alumni are our pride, who continue to share our values and significant contribution to the nation's